denominators with repeated and quadratic factors. So we want to see how we can be able to effect the partial fractions breakdown where we have the denominators with repeated and quadratic factors. A basic example is this one. You can see they want us to express 15x squared minus x plus 2 all over x minus 5 into 3x squared plus 4x minus 2 in its partial fractions. So as you can see, this is a quadratic factor that cannot be factorized. We cannot be factorized this one. So this kind of the quadratic factor where we cannot be able to factorize to always give rise to a partial fractions of this form. They will give rise to a partial fraction of ax plus b over ax squared plus bx plus c. They always give partial fractions of this form. So if this is the case, then we can express this one. But as again you can see, when you open the bracket, you realize that the degree of the numerator is less than the degree of the denominator, because when you open the bracket, you can see we have x cubed somewhere. Therefore, there's no need of division. We just move on and do the calculation. Now, so x, 15x squared minus x plus 2 over x minus 5 into 3x squared plus 4x minus 2. So this one gives rise to a over. This one is a linear factor. Remember, we have said that every linear factor will always give rise to a single partial fraction. Therefore, x, so we shall have a over x minus 5, then plus. Now, this one is a quadratic factor that cannot be factorized. So this one gives rise to a partial fraction of this form. So it plus now it will be bx plus c over 3x squared plus 4x then minus 2. So our duty now is to find the values of a, b, and c. So once again, you multiply through by the original denominator both sides of the Qn equation. So when you multiply this on both sides, so this will cancel itself, then we remain with 15x squared minus x plus 2 equals to a into, when you multiply this by this fraction, so this and this will cancel, then we remain with 3x squared plus 4x minus 2, then plus bx plus c into, when you multiply by this will cancel with this, and then we remain the x minus 5. X minus 5. So at this point, we now open up the bracket. So we have a times 3x squared. So we should have 3a x squared, then plus a times 4x. We have 4x, and a times negative 2 minus 2a. Then we have bx times x. We have plus bx squared, bx times negative 5 minus 5 bx. Then c times x, we have plus cx, c times negative 5 minus 5c. So at this point, we now collect like terms. Those that have x squared, we have this, and then we have that. So this equals to 3a, then plus b. Of course, we factorize out x squared like that. Then the next one, we now select those that have x. We have plus, we can see we have this, have 4a, then we have this minus 5b, then we have plus c, then factorize out x because it's common. Then we have constant terms, the one that you don't have the value x. We have minus 2a minus 5c. We are done with that. So once we have done this, then we equate the corresponding coefficients of x. So the highest power of x is x squared, so we shall start with x squared. So we shall have 3a plus b equals to 15. B equal to 15. Then those that are x, 4a minus 5b plus c equals to negative 1 there. Then lastly, the constant terms, we have 2 minus 2a minus 5c equals to positive 2. This is equation 1, equation 2, equation 3. So every time we have 3 unknowns, then we need to have 3 equations to enable us to get the values of unknown. So from here we can make beta subject in the first equation. Therefore b will be equal to 15 minus 3a. So when there is b in the second and third equation, we replace by 15 minus 3a. So we can start with this one. We have 4a minus 5. We can now replace the value of b, which is 15 minus 3a, like that. Then plus equals to negative 1. Can open up the bracket here. So we have 4a minus, we have 15 times 5, this is negative 75, then plus negative 5 times negative 3a, we have plus 15a plus c was negative 1. Then we have 4a plus 15a, we have 19a, then plus c equals to, now negative 75 closer to the other side, it becomes positive, so it will be negative 1 plus 75. So 19a plus equals to 74. Call this one equation K. Again, we substitute the value of b in the third equation. Given that, so we have the third equation, we have minus 2a minus 5c equals to 2. Can make C the subject in equation K. So C equals to 74 minus 19a. So that is the value of C. So you can write there is C in this equation, we replace by 74 by minus 19a. So we have minus 2a minus 5 into 74 minus 19a equals to 2. So minus 2a minus, take 74 times negative 5. 5 times 4 we have 20, 2, 5 times 7, 35 plus 2, 37. Then plus, we have 5 times 9. 5 times 9 we have 45. and 4. 4 times 5 times 1, we have 5 plus 4, have 95a equals to 2. So minus 2a plus 95a will remain with 93a equals to 2. When negative 370 goes to the other side becomes positive, plus 370. Therefore, 93a equals to 372. So a equals to 372 over 93, which equals to 4. When you divide 372 over 93, then we have 4. You can confirm that 372 divided by 93 is equals to 4. So if a is 4, then we can get the value of c here. The value of c then will be equal to 74 minus 19 times 4. 19 times 4. So we have 19 times 4 is equals to 76. So we have 74 minus 76 equals negative 2. So c is negative 2. So once we have them, then we can also get the value of b. The value of b can get it from this expression. So b equals to 15 minus 3a is equal to 15 minus 3 times our value of a is 4. So equals to 15 minus 12. So b equals to 3. I've said a equals to 4 and then c equals to negative 2. So once you have the values of unknown, then we go back and substitute in the given expression. Therefore, the partial fractions for 15x squared minus x plus 2 over x minus 5, 3x squared plus 4x minus 2 equals to, we have a over this. Our a is 4 over x minus 5, then plus b is 3, so it will be 3x plus our c is negative 2, so it will be minus 2 then over 3x squared plus 4x minus 2. So these are the two partial fractions for the given expression. Thank you for watching.